Hi everyone. I think I'm live. Uh, it's been a while from the last video because I was a bit busy with the other work. I also not been exploring Kafka in a while, so got a time in last week explored few stuff. So I thought I'll discuss here. Um, let's discuss about today Kafka producer, right? Uh, Already we have seen basic terminologies like what is Kafka, basic terminologies, where do we store and stuff. In this video, let's see about something called as producer, which pushes data into the Kafka. Basically, which produces the data, right? Mm, Let me share my screen. Yeah. Before that, this video is gonna be, I think, two part, probably. I may not guarantee. Three part as well um, because the technical depth that I want to explore is little bit more. I want to go till the OS level stuff, network level. So, but I'll try to include that. If that is deeper, I can't help much. In third video, we'll get to see the implementation because the ultimate. The ultimate way to learn a thing is to make it code. Concepts just teaches you things happening behind the scenes. Let me share my screen. We'll quickly start with that. Yeah, I think my screen is visible. So let's create with this. Let also open Accelerator Notepad. So we'll start with here. Um, okay. So basically, producer is nothing but a program with help of which we push our data into Kafka cluster. So I have a data. I need to push it. In order to push that data into a Kafka cluster, Kafka server cluster, whatever. I need a program, right, from to, that does this action. So that's nothing but a producer. It has a flow. So imagine you have a data. So this basically has some small details like topic name, key, value, partition. I think this is optional, or I don't know. Let's see. Let's increase this. Yeah. Let's move this bit here so that I can easily draw that. So now let's name this as the the official name for this is producer record. Which is nothing but an object which has the data that you want to send. So here the I think the attributes are understandable. The each object that you want to send must have this topic name, the key and value, the partition. I'm not sure about if this partition is still there or not, but let's see. The topic name is simple, that in which topic you want to push this message. As I told, the Kafka cluster is the hard disk is divided into the different topics where you store similar kind of messages. The key and value. So key is mostly used to segregate. First thing, it's a unique and it should be, it's a distinguishable between the messages, a message between the objects that you send. The value is actually the message that you want to send. So okay, this goes to serializer. Pardon me if my spellings are wrong. Bad with spellings usually. So this is a serializer where um, I'll tell you what happens in the serializer. So, so the producer has to send it to Kafka broker, right? And this sending has to be be fast. So the Kafka broker. What do you mean by producer sending a data? To whom it's sending? It is simple. Producer sends data to Kafka broker, which again a software which takes this and store it in this. That's the part. That's the part of the broker. This is wrong. Kafka broker doesn't send data to consumer. the yeah, it's fine. Um, to whom it is sending? I think this answer. What do you mean producer sending a data? So producer doesn't send data to disk. As I said in my previous discussion, Kafka is usually fast and this operation should be fast. You don't directly write to the disk. Broker is there, Kafka broker is there to take care of that. So imagine, right? So now here now comes the communication part. So if I'm talking in a language, if I'm sending information me to you in some language, there should be some sort of understanding between both of us. In the sense, if I start teaching you in Spanish, you don't understand because you have no idea in Spanish. And then what's the point of you receiving the messages? So there should be a common way, or to be specific, there should be a common understandable terms between producer and consumer, that producer produced information understood by consumer when it consumes. So it's called a serialization. It's simple. It's converting your data into bytes, easy to transfer. Why is it needed? Okay, first let's see why data needs to be serialized. Imagine you're sending a JSON object or custom data. It has to, once the broker is storing in the thing in the disk, and if you are reading from the disk, that also you will do by Kafka broker only. Once you are doing this, the consumer need to parse the data, need to understand the data. So if I store a JSON object, the consumer application should be able to parse that JSON object. So if I store in some other format XML, the consumer need to parse that XML thing. So I think now you would have got that. How is it possible? What? So we have to decode or the parts every type of data that producer is producing. That's impossible because usually these two are decoupled. There is no direct communication between producer and consumer is not aware of what data type or what data object the producer is producing. So it is difficult. So for that, there is a common way to do that in Kafka. Kafka does that. So whatever you send the message, producer don't has to take care of um, changing it, or whatever you send, it will be serialized to a byte array. And there is an agreement called as serialization protocol, and the consumer will also have the protocol. Consumer will refer to the protocol while reading from the disk. once you have the data, the serial data, you will see, oh okay, what is this? Then consumer will read the, okay, this is done using this. So it uses same decoding to decode or parse that serializable, that encoded data, and that is how it shows to the user. That's again a big story, this protocols and stuff that we'll discuss in the next video. But now I just wanted to show you, tell you that serialization happens. Why it is not be serialized? Speed sending, because it's Kafka is like high this thing, right? You don't bytes transfer fast in the medium than the custom objects. Second one is security. Your Kafka broker doesn't know what are you sending. You send any you send any message, irrespective of the message, it doesn't open the message and see what is inside. Again, when I say why is it just send the bytes as is, because the broker needs to be fast. Brokers need to be fast. Brokers needs to be fast. In second, I'm getting it. Broker needs to be fast. So that means how brokers will be fast. For every incoming message the broker is receiving, it has to parse that and see the data and again save it somewhere. So it doesn't parse any of your data. So the broker itself get the serialized array, the bytes array. So it need not to parse producer's data. And so producer bytes similar to Kafka broker. Okay, again. Uh, I'll show you this with an example, actually, how it is. There are two types of serialization things called as protobuf and Apache Avro. Avro. I'm not sure if this is or some of the okay. I don't know if this is the right word or not. Avro is the right word or not. But protobuf is a serializable format. See that thing that I told you that helps in serialization. Now let's get back to the diagram. So now here you have, okay, let me write a small thing here. Name just one thing. Message. Hello. Let me this should be big enough. So imagine you have this a message, and here after serialization, this becomes like this. This becomes like this. It got serialized. Then now there is something called as um, partitioner. Partitioner takes this message and assigns, already you have a topic name, and is assign the topic name, and it assigns the partition if you haven't assigned here. So usually keys, I told you, right? Key doesn't store any of the data. Key doesn't store the message that you want to store. key is just for identifying which partition it belongs to. Usually keys with same hash value go and sits in same partition. um, it works like that. So partition kind of, it's like, okay, you have to go, it directions, it attach the this data also, the topic name and partition to this. So partition sends this to a Kafka broker. So let's write here two brokers. It can give to any of the broker because broker is based on availability, not on connectivity. Now, the message being, oh, one second, let me write here. Topic partition one. Yeah, this is the data, and the same being sent here. Now, the broker, what broker does is, when broker receives this data, right? Broker doesn't go and save it in disk because it's slow. Broker is designed for fast, simple. Then how does it do that? So it batches all these messages in a queue or something. When the batch is full, when the batch size is full, Kafka runs a background thread which the only task is to check if this batch is full, batch is full, batch is full. If it is full, it goes and it does the operation of writing onto the disk. And the two, it doesn't write onto the disk, it writes something called as page cache. And again, the beautiful Linux will take care of this page cache, that you will set up all these things while creating the broker configuration, and it writes this in form of pages into the uh, disk. When the batch is full, uh, Kafka's background thread will do the job of storing this batch into disk. Look how beauty the things are being wired between things, right? For speedness, that is the actual that is what the beauty of Kafka is. And yeah, this is okay. After sending this, broker returns to the partition an object. What is census? Topic name it has returned to eprods. Partition one. Offset to which that message has been returned to. I don't know if I'll just store this and then let me increase the size. Yeah. Once the partition returns this message, the confirmation message by the broker, it means that this message is successfully written into Kafka, and the broker returns this message only after successfully saving it into the onto the disk. So yeah, as you said, this is a good understanding. This is a good point brought up, because your producer should never wait for the acknowledgement. It should be asynchronous. So it's okay. I sent. I cannot keep like 100 second. Let's say there are 100 messages, and each message is taking 1 millisecond, 10 milliseconds, let's say. So in order to the producer to know that 100 messages has been sent, it takes 1 second. That 100 into 10 milliseconds, 1000 milliseconds, which is 1 second. That is slow because 100 messages per second is slow. And yeah, so this should be asynchronous way of writing. There is a way how we can send the messages. There is a way we can pick method while sending this message. Should we send in asynchronous way or synchronous way? If we send it synchronously, for every message, this has to be got get from the background process or something, because it is the one what saves the disk. And assume the batch should get full, and this should go on really in page cache, and that page cache limit should be more than the person that we set. Then only all that page cache's content will be taken and returned to the disk. Before that, we won't get thing. And the application should not wait, right? The producer application should not wait for the response. It should not get hold of that. And the need of the background process here, background thread or process, it's not the process, it's a thread. The need of background thread is, um, once this the it's just to decouple the things. The It doesn't matter, right? If the sole necessity of the producer, the sole work of the producer is to produce the messages, just to produce the message, not to store the message. The part of storing that message is taken by the thread, and that's how this is high availability. Kafka is highly available. And yeah, I think this is much the flow. And in the consumer side, we'll see how this deserialization happen, how this bytes that we sent 0685101115 is converted, is again understood. This is sent by us, right? The consumer who is consuming this has no idea, because we don't agree as of now. But yeah, usually we agree on something called the serialization patterns. We'll see that. One more thing I want to discuss is, uh, this is just three ways of sending messages. I will also discuss that. And let's see a simple way of sending message to Kafka. So see here, uh, they created a properties object, and in the properties object, keeping the server names, the broker URLs. Let me tell you three things. I forgot to tell you. While constructing, we need to provide some properties that producer uses to establish connection with brokers. Even though you have more than one broker, you don't need to worry about providing list of all the brokers, because even if you provide with one broker, in the initial stage of establishing connection, the Kafka producer will get the list of all the brokers. That is how it's built. So one thing, three are must and should, because without these three, there is no point of storing information. Three pops are compulsory. Bootstrap servers. So bootstrap servers are nothing but your broker's URLs. So host and port, host column port thing. So host and pro, not port, host hyphen port, where you at least need to give two broker URLs, because if you give single, what happens is, assume because of some reason this broker is down. So you should not be in a case that you fail to establish connection to the Kafka cluster, because the brokers are there for that. Multiple brokers are there. So give minimum two. It's not a case that two brokers are down at a time. In that case, mm, I don't know, maybe retry mechanism has to be implemented, or it automatically retries, something like that. So retry means, I forgot something. If in the process of sending this, in the process of sending messages, if a broker didn't return the acknowledgement or response record, this is called as response record. This is called a response record. If partitioner doesn't get the response record, or the producer doesn't get the response record, it means that the broker has lost the message somewhere, or somewhere it failed to send the message, because ultimately that's a network communication, right? This is the communication. In that case, Kafka is smart enough to do retries. So there are basically two types of retries. One is this connection failures retries, wherein the next upcoming retries you'll be able to establish connection or something like that. Second exception is broker itself failed to write into uh, partition. That is because of this. Wait, let me write this. This is a good information. Producer is smart enough to do retries in case of failure in sending message to Kafka broker. Two types of retries, two types of exceptions to be specific. Retriable exception, non-retriable exception. In retriable exception, when, so in the first case, when you are creating the producer and you instantiate the producer object with the bootstrap server URL, it tries to establish the connection, right? If that connection establishment is failed, you cannot send the message, and whatever you send the message, all the messages will be lost. In that case, you can retry sending the messages, because the connection can be established in next retry. Whereas non-retrievable exceptions are like thread interruption exception. So the background thread that I am talking about, which has the role of taking um, the batch of these messages and put it into the page cache. If that thread got interrupted, there won't be any background thread running to clean up this batch or flush this batch. In that case, the batch size will be increased, and the batch will reach its maximum limit. You cannot store a message if the batch size is already in the maximum limit. So then you might get another exception, batch size exception, something. So here, that we'll discuss in the next thing. Or I think in the programmatically, I will also try to get the exceptions, because uh, it's good to see the exception. Thread interrupt exception, batch size limit exception. Retrievable exception is nothing but connection not found, or connection timed out, something. Yeah. Coming back to the properties, one is key dot serializer, value dot serializer. So you need serialization for key and value, right? For that purpose, you need to mention what serialization algorithm or protocol that you are using to serialize the key and to serialize the value. Let's see in this case, for example. So, yeah, they created a properties and property subject, and they kept the key as bootstrap servers, and they gave URL of two brokers, broker 1 and broker 2, which are running in the port. And for the key serializer, they kept this as a value. It is from Kafka serialization called a string serializer, which usually used to serialize if key is of type string. I'll show you. And same thing they are using for value serializer. They are also using the same thing. Value also might be a string, and they are creating a producer and passing this Kafka properties of parameter. Now let's see thing. So you are constructing a record um, with oh, okay. um, I think, yeah, I think this is key. No, this is the topic name, this is key, and this is value. So here the topic name is string, that is like obvious. The key value is also string, the value is also of type string. So since that's why they used here the inbuilt string serializer to serialize these two values, precision products and France. And you have a send method to send a record. And if any exception occurs in this process of sending, you are catching that and you are printing the stack trace. Again, this might be new for some people because this is, I think, Java, if I'm not wrong. We it's anything, right? Like the technology is not dependent on the language. You might be having similar with Python and other languages also. So as I told it, you can send each message synchronously, you can send each message asynchronously. So in order to send a message synchronously, as I mentioned here, you will be getting response record for every message that you send. So, and you should be liable, or you should be um, able to read the status of the response record. So it will be the same producer dot send record. With that, you will call the dot get function, which kind of gets that. It's a reply from Kafka. Here you can see dot get is wait for a reply from a Kafka. If the record is not sent successfully, this dot get method will throw exception. If there are no exceptions, it will return this object, the response record. Uh, I think this is same thing, retriable and non-retriable. Retriable uh, can be retried. Its name is obvious. Non-retriable cannot be retried. So in the same way, you can send messages asynchronously to Kafka. Let's read this, right. So for that, you cannot actually get a thing. So you want a callback for every thing that later got implemented, right? So from the org.apache.kafka, you need to implement this interface, and you need to override this interface. There is a method in this interface called as on completion, where you need to override like with what should happen once you return this. Do you want to print stack trace, or do you want to return that, or yeah, whatever. So in that case, the send has one more parameter called as record comma. This is the new callback, custom callback mechanism, custom callback thing. So yeah, I think this is it for this video. And here we understand how the very basic in the actual flow of data from producer to consumer, this is I think 40%. In the next one, we can cover what are more properties or configurations we can provide to consumer. We can provide to producer, and if time permits, no, time will permit, yeah. Serialization will be discussed, and code implemented if time permits. Yeah. This is the diagram that I used for today's string. And yeah, one question I have. I got this doubt and asked Gemini while I was reading this. So, why does producer should handle the serialization? Isn't it in a OSA model in the which layer? I think layer number six, presentation session. Yeah, in layer number six, presentation layer, isn't it data serialization will happen? So whatever you send over the network, that simply get converts to zeros and ones, and other side of the consumer or client or server takes up these zeros and ones and decode from that and builds the original object. Isn't it that how it's designed? So why should again we should serialize this in a from the application level? Uh, Question is good, but yeah, actually, even my answer is not clear. So I'll be sending over the in the comments like what is the answer I got. But this is a question. You guys also explore this. Why should producer implement serialization when presentation layer is already handling it? So my kind of answer is, yeah, like even I have, it's my question that I should have some sort of answer for that or some guess or something. My kind of guess for this is, um, you are not actually relying on the network side serialization. Yeah, obviously network side serialization will happen, but in the real world, the layers are not as specifically followed. If you see, the OSA model is just the rule book. It's not a compulsion. It's a rule book to design your applications or to happen communications between two systems. You can override that, or you can follow or not follow. Mostly TCP/IP only is only followed, in which the serialization will happen, but it's like, see, when you send to the serialization, this layer should unpack that and parse them and then convert into bytes. Whereas Kafka, the broker doesn't need all of that information. The broker doesn't even care about your the type of data that you are sending, because it doesn't take the effort to unwrap or parse your data. So this is what I'm guessing, but there will be more good reason for that, or the best reason for that, or we can even ask uh, Gemini now itself. If Kafka handles serialization, okay, what is need of Kafka producer to handle serialization when in OSA model presentation layer already does this. See, my guess was correct. I read this somewhere. The OSI model is just a rule book. It's up to the application or a whatever to include it or not. They mix the entirely presentation layer into application logic itself. So yeah, the OSM model is there to the network's job. Modern networking stacks designed to be dumb pipes. Their only goal to move raw bytes from A to B as fast as possible. As fast as possible. So here they overwritten that and they are skipping the compression or serialization itself. Schema because it treats every message as a blind sequence of bytes. If producer didn't cover your Java object or Python dictionary into bytes sending it. The network layer wouldn't know what to do with the complex memory object. Okay, okay. Got it. I think in what my thing is in normal application, two application will talk over a specific format of data. Since here the format is can be anything. I can send user object or student object with the data called as key value something to this, and network layer doesn't even know what is student object or user object. Kafka is designed to decouple consumers. Correct. This is true. Producer might be written in Java, consumer written in Go. Correct. Relation at the producer level, the data is turned into universal formats in language can understand period and low level presentation fix bit tied to whatever is sending input in the network structure support. Okay. But so written exactly as they are onto the disk on the Kafka group. Okay, to avoid this CPU overhead, because if they want to do it, the broker also has to need to break into that data and it has to see and it has to re put the data and send to customer, which is a CPU overhead. Save space. Okay, this is good. I think this line is powerful. The producer knows what the data is, while the OSA model knows only. Correct. Let me paste this here. Yeah. Yeah, I think we covered a decent amount of stuff in this video. In the next video, as I told, I'll be discussing these two, or I'll try to discuss these three also, and the part two. After that, we'll move to consumers and stuff. Came around 43 minutes. Yeah, thank you. Ending the stream.